We have another video here from a YouTube channel called The Impossible Builds. I reacted to one of their videos a couple of weeks back. You can go and check out that reaction video. I will leave the link in the descriptions down below. Today's video is titled Pakistan's 4.2 billion mega dam will change everything. Let's dive in and find out.
On the roaring Indus River in Kohistan, Pakistan is building one of the tallest roller-compacted concrete dams in the world. The Dasu Hydropower project stands at 242 meters high, with a crest length of 570 meters, a true engineering masterpiece designed to produce 4,320 megawatts of electricity. This dam will hold back a reservoir stretching 73 kilometers with a gross storage capacity of 1.4 billion cubic meters of water, enough to generate 21 billion kilowatt hours of energy annually once both stages are complete. The project's first stage, costing 4.2
I reacted to a video about dam construction a couple of videos back, and I remember I mentioned in that video that I have a soft spot for hydroelectricity. One of the main reasons is that it's clean energy compared to the use of fossil fuels. And I mean, one might argue that the process of dam construction itself is energy intensive, and it might lead to environmental degradation. For example, during quarrying of the concrete aggregates that are used in the dam construction and the production of cement, which uses coal. But on the other hand, I think the benefits outweighs the short-term negatives of during the construction phase, because you have at least 100 years of clean energy. That is a long time, considering the amount of materials that you have used and the amount of upfront investment in the dam construction. Not only that, it changes the surrounding communities as well. Think about all the job creation that comes from dam construction, and usually these projects, they take a long time, more than 5 years at the minimum, and that means a lot of people will have job securities for the next 5 years or so, and all these people will need food, housing, which means that the local economy of that area where the dam is being constructed will have an increase in its economic output, because all these people at some point will need food, clean water, and there are other aspects as well, like the development of surrounding infrastructure which supports the dam construction, like the improvement of roads that leads to the construction sites.
The project's first stage, costing $4.2 billion, is set to begin power production by 2027. Funding comes from the World Bank, which has invested over $1.7 billion, along with commercial banks and local contributions. Its massive infrastructure includes 8 spillway gates, 9 low-level outlets, and 2 diversion tunnels, making it a cornerstone for clean energy in Pakistan. But what makes this dam's turbines, tunnels, and cutting-edge spillway system capable of managing the raw power of the Indus River? Let's find out. Pakistan is a country with incredible potential, but faces a tough challenge: a growing demand for electricity. With millions relying on the power grid, the country's
Yes, I can completely resonate with this. I grew up in a third world country, and growing up, there were periods of time where we would go for 18 hours plus without electricity. And this was not a one-off thing where maybe there are other external factors that are causing loss of power, like let's say hurricanes or storms or whatever natural disaster. This was from the lack of the capacity to produce enough electricity for the whole populace of the country that I grew up in. you know, because now I live in a place where there's abundance of electricity, sometimes I forget to appreciate what a blessing it is to have that. So kudos to Pakistan in investing in such projects, because as much as sometimes people don't really understand the importance of electricity, it plays a pivotal role in the development and the well-being of the populace. You cannot have a proper industrial development without energy, especially in the form of electricity.
Struggles to keep the lights on for homes, businesses, and industries. The question is, how do you solve a problem this big, especially when the need for energy keeps increasing every year? That's where the Dasu Hydropower project comes in, a game changer, not just for electricity, but for the lives of millions. Now, picture this, a massive dam rising high in the rugged mountains of Khohestan, surrounded by the roaring Indus River. This is where the magic begins. The Dasu Hydropower project is located about 7 kilometers upstream of Dasu town in Khyber Pakhtunkhwa. It's not just any dam. It's designed to be one of the largest hydropower plants in South Asia, capable of producing an astounding 4,320 megawatts of electricity when fully completed. That's enough to power cities and industries across the nation. Here's how it all started. The idea for this project was born back in 2001 as part of Pakistan's Vision 2025 plan. After years of planning and studies, construction began in 2017. The project is being built in 2 stages, with the first stage already underway. When this stage is complete, it will generate 2,160 megawatts of clean, green electricity annually, enough to light up millions of homes while cutting down reliance on costly fuel imports. And once both stages are done, Dasu will stand tall as the biggest energy producer in the country. But it's not just about electricity. Dasu is creating thousands of jobs, boosting the local economy, and building roads and housing in this remote region. It's transforming lives and bringing developments to areas that were often overlooked. People in nearby communities are gaining access to new opportunities, and the project promises long-term benefits for the entire country. So, what makes this dam so special? What engineering marvels are hidden behind its towering walls and winding tunnels? That's where the real story begins. The Dasu Hydropower project isn't your ordinary dam. Standing at a massive 242 meters high and stretching 570 meters along its crest, it will become one of the tallest roller-compacted concrete dams in the world. Think about that for a moment. It's like stacking a 60-story building in the middle of a river. But it's not just size that makes it impressive. The entire design is built for power, efficiency, and sustainability. Let's break it down. First, imagine a river as powerful as the Indus. To harness its strength, engineers constructed 2 enormous diversion tunnels on the
Yes, this is common in dam construction, especially in such topography where you are in a valley. You cannot just construct a dam when the water is flowing. So what you do is you construct some tunnels that will divert the water. Then you create what are called cofferdams. Basically, you are blocking on both sides of the river, the upstream and the downstream. Then you pump out the water, then you create a dry area to work in. One of the advantages of doing this is if you properly design it, those divergence tunnels would then be used as tunnels which would feed in water into the hydro station to generate the electricity.
Constructed 2 enormous diversion tunnels on the left bank of the river. These tunnels, over 1.5 kilometers long each, are like giant water highways, rerouting the Indus temporarily so workers could safely build the dam. Once completed, the dam will create a reservoir stretching 73 kilometers upstream, with enough storage capacity to hold over 1.4 billion cubic meters of water. That's an unimaginable amount of energy waiting to be unleashed. Here's how it works. Water from the reservoir will flow through 4 massive head race tunnels, each shaped like a giant cylinder, into the underground powerhouse. This powerhouse is a cavern carved into the rock, big enough to fit several football fields. Inside, it holds the heart of the project, 6 state-of-the-art turbines in Stage 1, each capable of generating 360 megawatts of electricity. These turbines spin when water rushes through them, converting the river's raw power into clean, green energy. And this is just the beginning. Stage 2 will add another set of 6 turbines, doubling the energy output to 4,320 megawatts. But how do you control such a massive flow of water? That's where the spillways and low-level outlets come in. The dam has 8 spillways.
Yes, spillway is one of the most important parts of dam construction. The purpose for spillways is to remove the excess water behind the dam wall. Sometimes you have flood events upstream, which means that will increase the volume of the water stored in the dam. And you don't want a situation where the water overflows on top of the dam, because that will cause a lot of destabilization. So a spillway usually designed in a way that when it deposits the water on the other side, it doesn't cause erosion or back circulation, which then compromises the foundation of the dam and causes instability. There's a recent case in the US, I'm forgetting the name of the dam. The spillway concrete surface peeled off, then the water started eroding the soil material underneath. And luckily, they managed to get the situation in control, because there was danger that the erosion was propagating towards the dam structure itself. And that dam is a earth embankment dam, which means it's made from soil and rock materials, which can easily be eroded, unlike concrete structures.
Spillway gates and 9 low-level outlets, all built to handle the river's full force during floods. These outlets aren't just regular holes, they're engineered with advanced radial gates that can control how much water is released. To keep the reservoir functioning smoothly, there are also 2 flushing tunnels designed to clear out sediment that naturally builds up over time.
And this is another thing which is important as well for dam structures. You see, when the water flows from the upstream in the river, it carries some material with it. When it reaches the dam structure, it loses that kinetic energy and therefore losing its carrying capacity. And all those materials which were in suspension would then settle at the bottom of the dam. And over time, that builds up. If that is not dealt with, it will increase the pressure on the dam, the lateral pressure on the dam, which might lead to the instability of the structure itself. I actually didn't know about this kind of design. It's quite interesting how they designed to deal with this problem, because it's a huge problem for a lot of dams, especially dams which were built more than 5 decades ago.
It's like giving the dam a regular cleaning so it keeps running efficiently for decades. The technical precision doesn't stop there. After spinning the turbines, the water doesn't just stay trapped. It's channeled back into the Indus through 4 trail race tunnels, each nearly 3 kilometers long. This ensures the river's flow continues downstream without interruption, keeping ecosystems alive and communities reliant on the river intact. Even the construction itself is a marvel. The dam uses roller compacted concrete, a special type of concrete that's poured and pressed layer by layer to create a structure strong enough to withstand immense pressure. Over 4 million cubic meters of this concrete will be used. To put it into perspective, that's enough material to build a road stretching hundreds of kilometers. Then there's the transmission system. What good is all this energy if it can't reach people? Engineers have designed a 500 kilovolt transmission line running parallel circuits for over 250 kilometers to carry the electricity to the national grid. This ensures power generated in the mountains lights up homes, factories, and schools across the country. And let's not forget the human side. Building this dam isn't just about power, it's about progress. Thousands of jobs have been created, with many going to local workers. Roads, bridges, and new housing have been built to support the workforce and improve the surrounding area. The project includes a resettlement program for families impacted by the construction, ensuring
Yeah, the resettlement of people is usually a controversial matter when it comes to building dams. And it's one thing that is inevitable because, usually these dams, yes, they are built in more remote areas, but then they shouldn't be too far away. Otherwise, you face the problem of costs. Because if it's too far away from the resources that you need, then it means that there's an increased cost in transportation of the materials needed. So in most cases, some people have to be relocated to new areas, those who are closer to the construction site and those who are situated in the area that the reservoir is going to flood.
they benefit from the developments rather than being left behind. What about the cost? The Dasu Hydropower project's first stage carries an estimated cost of $4.2 billion, a monumental figure requiring diverse funding sources. The World
Yeah, which is a lot of money for developing countries. For first world economy, it's a lot of money, but it's something that is manageable. But for third world countries and developing countries, it's a catch-22 because this type of infrastructure are exactly the things that you need in order to develop. But at the same time, you don't have money to fund for the things that you need to develop. So funding is usually the hindrance to the development of some countries. Yes, you can get funding from World Bank, the International Monetary Fund. They usually fund these projects in developing countries, which is good. I wish there would be more funding which goes directly to energy security in form of construction of these kind of massive projects.
Bank has been a critical partner, providing $700 million in financing specifically for infrastructure and the 765 kilovolt transmission line that will distribute the power generated. Additionally, an International Development Association credit of $588.4 million and a partial credit guarantee of $460 million from the World Bank have further bolstered the financial structure. In June 2024, the World Bank approved another $1 billion in financing to ensure timely progress, particularly for land acquisition and advanced construction stages. This collaborative funding effort ensures not just the construction of the dam, but also the extensive transmission and resettlement infrastructure necessary for its operation. While the price tag is enormous, the expected output of clean, affordable, and sustainable energy makes it a viable investment in Pakistan's future. The dam is expected to begin producing power by 2027, with the first stage generating over 12 billion kilowatt hours of electricity annually. When stage 2 is complete, the total output will reach an astonishing 21 billion kilowatt hours. That's enough energy to significantly reduce the country's reliance on fossil fuels and cut down on costly energy imports. But this project isn't just about solving today's problems. It's about building a future where energy is cleaner, more affordable, and more reliable. A future where remote areas benefit from development and communities thrive. The Dasu Hydropower project is more than a dam. It's a symbol of what's possible when innovation meets determination. So the next time you flick on a light switch, imagine the journey that electricity took. Rushing down from the towering heights of Dasu, through turbines, along transmission lines, and into your home. Isn't that incredible? If you found this fascinating, don't forget to like, subscribe, and hit.
Yes, this was fascinating. I recommend you go check out this YouTube channel. I think they make really good construction videos. I will leave the link to this video in the descriptions down below. And kudos to Pakistan, man. I'm always fascinated in investments in these kind of projects. One of my motivations to get into engineering was because of the thought and the idea of doing something that means a lot to a lot of people, helping out in as much as I can. I'm really interested in this kind of projects which increases the quality of life to the majority of the populace, because at the end of the day, I think that's what life is, mostly about, right? Just making sure that most of the people have a decent life, and electricity is a game changer. I don't think you can fully understand the importance of electricity if you haven't lived in a place where there's no electricity. The lack of electricity just slows down almost everything. The difference of having sustainable energy and not having one is night and day. It's actually really difficult to explain in a way that someone who hasn't been in a situation where they can spend up to 18 hours a day for 7 days a week without electricity can really fully comprehend the magnitude of that. But anyway, thanks for watching the video. Please leave a like and subscribe to my channel. My name is Chido Chashe. I'm a geotechnical engineer, and I'll see you on the next one.